This demo showcases a process of generating an optimized flight route for autonomous drones. The system allows users to select a series of path points and define the flight altitude, after which an optimized route is automatically calculated. The route generation process is based on a cost optimization algorithm that utilizes a three-dimensional environmental model represented as a graph. This model incorporates various parameters, including progression costs and restricted areas that must be avoided, such as obstacles, no-fly zones, and regulatory constraints. A key feature of this system is its ability to adapt to real-time conditions. The model can be updated dynamically to reflect changes in obstacles, weather conditions, or temporary flight restrictions. In scenarios where mobile reception is a critical factor, the route can be adjusted based on the current network status and real-time antenna reception data, ensuring continuous and reliable communication throughout the flight. By analyzing these factors, the algorithm identifies the most efficient path that balances multiple objectives, such as minimizing flight time, reducing energy consumption, and ensuring compliance with operational restrictions. Once the initial route is generated, a smoothing process is applied to eliminate unnecessary turns and create a more efficient natural flight trajectory. This system is particularly useful for applications requiring precise and adaptive UAV navigation, such as urban logistics, infrastructure inspection, and surveillance. With the ability to integrate real-time data and adjust routes dynamically, it enhances operational efficiency and safety for autonomous drone missions.